The new unit is going to be operations on functions, and it's critically important that we understand what is a function. Now, a function has many sort of applications, and we can graph them, we can algebraically manipulate them, and really, what should we know? Well, we should know all of it about a function. So I'm just going to do a brief overview of what is a function here. A function is a critically important concept in math. It can be thought up in many ways. Fundamentally, it takes a set of instructions that takes an independent variable and maps it into a dependent variable. Now, normally we map an x into a y. How is x mapped into a y? Well, through this set of instructions. For example, let us talk about our function g, g of b. So what do we know? We know that we have an independent or input of b, and g takes this b and then multiplies the b by 2, squares it, and then adds 4. So this is really the set of instructions for g, and we call it a function. So g of b is equal to 2 times b squared plus 4. G would be the function. So let's go on to the next example. Let's consider the following function. Now we have another function g, and typically we don't like to call functions in the same conversation using the same letter. So to avoid confusion, I might call it h. So h is equal to, well, h is a set of 4 points. -2, 1, 1, 9, 3, 2, 4, 0. Identify the domain and range for g. Well, the domain is all the inputs that are allowed, and typically inputs are x's. So the domain for this function is going to be -2, 1, 3, and 4. These are the inputs that are allowed in my function. My range is going to be, well, the outputs or the y values, which would be, my range would be 0, 1, 2, 9. So identify, I hope that's good. So let us identify the h of 1. So here, my input is 1. So I go in my list and I look, when is my input 1? My input is 1 there. Well, what is the output when my input is 1? So in this example, h of 1 is equal to 9. In my function h, when I input 1, my output is 9. Now, I know that this is not typically what you think of a function. You always want it on a graph likely, but a function can have many forms. Now, still using the same set, so I say identify h of 0. Well, in my function h, when I look, I ask myself, when my input is 0, what is my output? Well, here, my input is never 0. So what is h of 0? It's best described as undefined. So a function is a relationship that exists between two variables, typically x and y. Further, a function maps a specific x value into a unique y value. So every time you take an x value and plug it into a function, expect the same y value out. To test if a relation is a function, we're going to employ the vertical line test. So I have my function g here, and I'm just going to map put my points down. So this is my function. Now, it's an odd function, no doubt, but what is an additional point such that g is no longer a function? Well, there's actually many additional points that we could do that, but I'm just going to maybe make an additional point right here. Now, what makes this not a function? So I'm just going to say -2, 4. What makes this not a function? Well, you would say, well, it fails the vertical line test. But more concretely, for an x value, there are 2 y values, which is not allowed in a function. So the input of a function is the independent variable. The output is called the dependent variable. The set of all possible independent variables, or all possible inputs, we call this the domain. The set of all possible dependent variables that are determined by the function is described by the range. Finding the domain is going to be straightforward. So at times, like the example above, you can easily pick out the x values. Where it gets a little bit more complicated is when there are restrictions upon the x values.